So after the horror show that was the last question, we'll move on to the next question, question 8, which is financial maths by the looks of it. Okay, that's nice. Financial maths is always nice to get a long question first, so we'll do that. We're told these people have bank accounts. Okay, perfect. So hopefully I still have the tables book here. I do, perfect. So we're gonna use the very first formula for compound interest. So f is equal, just write the formula first of all, present value multiplied by 1 plus I to the power of t. So basically to do this, p, this is the present value, this is how much it's worth at the moment, this is the interest rate, and we're told the time is 5 years, that's t. So literally all we do, just sub into our formula. So 3,000 multiplied by 1 plus 2.4%. It was 2.4, wasn't it? Yeah. And that's going to be to the power of 5. And now we put this into your calculator, that will give you the amount of money in her account. So putting that into your calculator and then rounding it to the nearest one is going to give 3377.70 to the nearest cent. Okay, that's how you do that one. Straight up, just right into it. Then next part is one of the English questions. We're asked to explain what is meant by the present value of a payment of 1,000 in 1 year's time at a particular interest rate. So I talked a bit one of the days we did financial maths about this, and I said basically when you're paying back a mortgage, or if you're paying back kind of a loan, if you think of the money kind of in these boxes, okay, let's suppose we have 5 payments. So let's just say we have a 5-year mortgage, and at the end of every year you make one of these payments. So you put the money in this box. Okay, and let's say, for simplicity, that each payment is €1,000. Okay, and then so on. I won't do the last two. So we pay this back at the end of this year. We're going to pay €1,000. But if we, let's say, our great aunt dies and leaves us a lovely sum of €10,000, we might say, okay, let's pay off the loan. Let's use this money and let's just get rid of the loan. You actually don't have to pay back the €1,000. You're going to pay less, because basically the money will, with interest or whatever, it'll go up to 1,000 after a year. So when at the moment it's not worth 1,000 because of inflation and stuff, but when it comes to a year it will be 1,000. So basically, if we were to say what the present value is, it's basically all we could say is it's essentially just how much €1,000 how much €1,000 in a year, let's say in a year, is worth in today's money. In today's money. That's basically it. Because the interest rate will make it go up to 1,000. So we basically just whatever it is before interest. And then in the American scheme, it kind of says something similar. Yeah, it kind of says how much however much should be invested. Yeah, it's the same thing. How much 1,000 is worth in today's money. That's all it is. Then we're told that Shen puts a different amount in a savings account with the same interest. So he puts in P. Okay, just figure out what things are. This is I, this is T, and this is F. So we're going to use the same thing. Use the exact same formula. F is equal to P by 1 plus I to the T. Now F, we're told, is 4,000. Actually, sorry, you know what we'll do? We're going to use a similar formula, because it's going to make it easier. It's derived from the first formula, but anyway, we're going to use this one here. So we're looking for P. So all we do is sub in. So what's F? 4,000 divided by 1 plus 2.4% raised to the power of 6, because T is 6. And yeah, put that into your calculator and you'll get €3,469.45. Nice. Okay. Then we're sold, yeah. Oh, interesting. Fiona's taking out a loan at the same annual interest rate, 2.4% a year. She decides to make payments quarterly, 4 times per year, and then we're asked to work out the quarterly interest rate that would be equivalent to an annual percentage rate of 2.4. So this was our formula, 1 plus I. It's going to be to the 4 this time. I think earlier when we did them, usually it's monthly and you do it to the power of 12 because there's 12 months in a year. This time we're going to do it to the 4. Interesting. I didn't actually know that they asked it different than monthly. They won't realistically, they're going to ask it for monthly, but just so you know, this is how you do it for yearly. And now what we do is we sub in. Let's double check my formula is correct. Sorry, I did the same thing again. I think I did this when we were first doing it as well. I'm after writing it the wrong way around. So it's 1 plus I is equal to 1 plus S to the power of 4. Okay, my bad. So then what we do is put this in, 1 plus 2.4%. We're looking for S. So to get S on its own, what we do is we raise both sides to the power of a quarter. And that gets rid of that, that gets rid of this, that's the trick. And then move the 1 over, okay? And then when you put it into your calculator, make sure you multiply it by 100 to get the percent. So that will give S is equal to 0.005947, but they want it as a percent. So to do that, we do it as 0.59%, like that. Yeah, so make sure we learn off this formula here. Yeah, that's all good. Then Rohin wants to put the same amount of money in a savings account at the start of each month for 36 months, so that at the end of 3 years he will have 12,000 in the account, and we're told that interest is calculated at a rate of 0.11% per month. Then we're said, taking A to be the amount that he puts in at the start of each month, write down a geometric series in A to show, okay, so first of all, the start of each month, to show the total amount of money in the account at the end of 3 years, and all we're asked to do is include the first 2 and the last 2 terms. So what is it? It's a savings account. So he puts in some amount and it'll go up by that. Yeah, perfect. So I don't know which way they want this. So basically, yeah, so the first amount, he puts in A. So when he puts in this amount, right, so let's just say he puts in €100. It's over 36 months, okay? So every single month, this €100 is going to appreciate in value, okay? So let's say after the first month, it's 101, okay? Now it's going to go up again, now it's 103. Oh, okay, now it's 107, like it goes up each month. So the very first payment he puts in is going to appreciate 36 times. So that's what's important here. So to get the first value, it's going to be 1 plus 0.11%. And that's going to be to the power of 36 because it's going to do it 36 times. Then it's going to be 1 plus 0.11% to 35 because the second one he pays in is only going to appreciate 35 times because he puts it in the second month. Then we're told to include the last 2 terms. So what's that going to be, I wonder? Okay, I think the powers are going to be, it should be 2 because he puts it in, yeah, that should be 2, and then plus A by 1 plus 0.11%, and that's going to be to the power of 1, so we have to write everything as right as that, and that's going to be because it depreciates each month. Yeah, that looks right. Yeah, perfect, that is exactly right. So that's how you do that one. So basically, this one here is going to be the very last one he puts in. So every single month for 36 months, he puts in he puts one of these, he puts kind of these in. I'm not going to do 36 of these, but he does them like this. He puts one of these in every single month. The first one he puts in is going to get interest on it 36 times. The next one he puts in is only going to get interest 35 times, the next one 34, and the very last one he puts in is only going to get 1 month of interest on it. Okay, that's how these work. So then we're asked to find the value of A that will give a total of 12,000 in the account after 3 years. So to do this, we see this thing we have up here, we equal this to 12,000. And yeah, there's obviously, you could multiply that entire thing out. You could do every single one of these terms for 36 different numbers and do it that way. Not the best way to do it though. The way we're going to do it is using the geometric series formula. So if you go to your tables book on page 23, you'll find this formula here. So this is what we're going to do. Now, we can do it 2 ways. I guess I've kind of committed to doing it this way. So basically, you see the way when I wrote this, you can write it like this, or you could write it backwards. So we could have written, see this number here, we could have written this one over here, and that probably would have made it a bit nicer, but it doesn't really matter. So A is our first term. Okay, so let's just write out what A is. So A is our very first term, which is A. And then if we just see the way I have like the plus the percent, if you put that into your calculator, it will give it to you like this. I'm just going to do this because it's going to be nicer. So this is A. Okay, then OR. OR is the ratio, or how you get to the next one. So to get to the next one, we actually divide by the ratio. So that's the ratio there. That's going to be because we go from 36 down to 35. So if we want to get from here to here, we multiply by or 1 over, like that. Okay, that's why I would have thought it would have been a bit nicer to do the other way, but it doesn't matter, it's still okay. Now all we're going to do is stick this in SN, we're doing the first 36 payments, so it's S of 36. Okay, then we put A in, which is this capital A, times this thing to the 36, then multiplied by 1 minus 1 over 1.0011, and then this thing to the power of 36, and then all over 1 minus or, which is 1 over 0011, and then we equal that to 12,000. And now what we have to do is rearrange and get A on its own. So to get A on its own, what you do is you multiply, see this thing here? Multiply 12,000 by that. And then what we do is, see this kind of big thing here? We're going to divide by that. So first we cross multiply. So that's basically the first step. First step I put in the box, cross multiply, and then cross divide. That's all you have to do. And then if you put that, so I'm gonna rearrange it very quickly, and I'll just show what you should put into your calculator. So we should write A is equal to 12,000. Then it's going to be multiplied by this here, which is our denominator. And then it's going to be divided by 1.0011 to the power of 36. And then divided by 1 minus 1 over 1.0011 to the 36. So you just do it opposite basically. And if you put that into your calculator and round it to 2 decimals, you will get 326.60. I believe. I'm just double checking. Yep. Yeah. Perfect. Then we're almost done this question. This actually isn't too bad of a question. This is quite a typical financial maths question as well. So we're told a park sells 3 types of tickets: a children ticket, a student ticket, and an adult ticket. It shows the information on the price of the tickets and the percentage. Okay, and then we're told the expected value of the price of a ticket is 13.85. Work out the value of X, the price of an adult ticket. Perfect. So remember, the expectation or the expected value of X is equal to basically X times the probability of X. So what you do is you just kind of add all these things up. So first of all, it's €11 for the first ticket, multiplied by the probability of it, which is 0.52. Then for a student ticket, it's €5 less than an adult ticket. So an adult ticket is X euro. So to get however much a student ticket is, it's going to be X minus 5. So then it's going to be plus X minus 5 multiplied by 0.15 plus X times 0.33. And we actually know that this is equal to €13.85. So now what we're going to do is just multiply this out. So I better do it step by step. So 11 by 0.52 is 5.72. So this is going to give me 5.72 plus 0.15x. 5 times 15 minus 0.75 plus 0.33x is equal to 13.85. Now move the x's to one side and the numbers to another. So on this side we're going to get 0.48x is equal to 8.88. And that gives x is equal to 1850. So we divide by 0.48 to get that, by the way. So €18.50. Now, when an item is being sold, the markup is the profit as a percentage of the cost price. So we have two things, we have cost price, and then the margin is the profit as a percentage of the selling price. Okay, so a cost price is how much it costs the shop to buy, and a margin is how much basically so cost price, how much it costs to buy, selling price, how much the shop actually sells it for. So the difference between the cost price and the selling price is the profit. So I'll just point that out. So the selling price minus the cost price is actually just profit. The only thing we're told is that the margin is 18%, and then we're asked to work out the markup. That looks like such a little amount of information. Crazy. So I suppose you could use it. You could use a lot of maths to do this, but I think there's a simpler way of doing it. So let's just imagine a shop buys something for €100, and we know that their margin is 18%. So the margin, what we told, that's the profit as a percentage of the selling price. So if they buy it for 100 and they have a margin of 18%, that must mean that they sold it for 118. I think. Yeah, that looks right. So that must mean they sold it for €118. That is, if it's 100, that's if the selling price is 100. Okay. Now we're asked to work out the markup for this item. Okay, first of all, in this case, we said they sold it for 100 and they made a margin of 18%, so overall they made €118, and we're trying to figure out basically what their profit is. So yeah, it seems like we need to know the profit for this. Well, what was their profit? Interesting. Yeah, I'm thinking about doing this algebraically now, to be fair. Oh, okay. Oh, sorry. So, okay, let's say they made €18 profit. So if they made €18 profit, oh yes, okay, perfect. Now I can actually, this one I had over here, the selling price minus the cost price is the profit. Okay, this is interesting. So now I could say the selling price was 100. So the cost price in this case must have been €82. Okay, so that must mean if we sold it for 18, or if we bought it for 80, we bought it for 82, sold it for 100, and that must mean we made €18 profit. Okay, so now Now what we're trying to do is find the margin. Oh no, sorry, we're trying to find the markup. So the markup is profit as a percentage of the cost price. So profit, what was our profit? 18. What was our cost price? 82. As a percentage, multiply by 100. And that gives us 22%. Okay, that's how you do that one. Start complicating it there, that's all you have to do.